Morning class. I'm just going to use homework 10.3 from MathXL if you want to use the printout or just draw them on your own paper. But picked a few questions off of the MathXL to practice to teach you this lesson. This lesson is called Area of Sectors of Circles. And so just like in our previous notes, we looked at finding arc length. So for instance, the length of this piece of a circle back when we were in class a few weeks ago. And we said to get that arc length, that was equal to the degree of the arc out of 360 times all the way around the circle, which was the circumference, times the circumference. So that was old information. Today what we're going to do is very similar. We're going to find the area of what we call a sector. And a sector is just a part of a circle. So for instance, the area of a sector, instead of being the outside of this circle, I'm now looking for this part of the circle. So if you think about that, I'm looking for a chunk of the area, because the area is what's considered inside. So an area of a sector is very much like arc length, except I'm not talking about a piece of the circumference, I'm talking about a piece of the area. So to get the area of that shaded region up there, I would do basically the same thing. I'd find the degree of the shaded region, which is out of 360, and instead of times it by the circumference, I'm going to times it by the area, because I want a part of the area of the circle. Okay, now we talked before, area of a circle, we have to get that formula, and the area of a circle, if you look at this yellow sheet I have here, the area is equal to pi r squared. So I'm now going to replace this with area of sector is equal to the degree out of 360 times, and instead of area of a circle, I'm going to put the actual formula, pi r squared. Okay, that formula right there is worth writing down. If you have not been writing anything down, that is worth writing down, because that's the formula we're going to use throughout this MathXL. All right, so I got that over to the side. The one at the beginning are just plain old find the area. So no sectors on this one. They just want the area of the circle. So you're going to find the area of the circle, which means you're just going on number 1 and 2, which means you're just going to use pi r squared. A equals pi r squared. No degree, because you're finding the entire thing. So I believe the picture looked like this. I think 3.1 was all the way across. My printer didn't print very good, which means 3.1, I'm doing number 2, by the way, which number 1 is very much like it. That would, if this is all the way across, 3.1 would be the diameter. So remember, you take 3.1 and divide it by 2 to get the radius. So 3.1 divided by 2 is 1.55, and that would be our radius. And now I would just sub it in over here. So A equals pi times r, which is 1.55 squared. And 1.55 squared, I have 2.4025, and then I would put a pi with it. So it says answer and exact answer in terms of pi. So that would be your exact answer. All right, so that's if they give you a diameter. Remember, if they give you only half of this from the center out to the side, they already gave you a radius. So that'd be the number you use. Okay, so now let's deal with an example for a sector. So I'm down on number 4 now. So number 4, notice that they don't want the area of the whole circle, they just want the area of GPH, this chunk that's in blue. So that means I'm going to do this degree out of 360, what part of the sector do I want, times it by the area, pi r squared. So area of sector equals our degree out of 360, so it would be 80 degrees out of 360 times pi r squared. And n for r is our radius, and the radius here is 15, so 15 squared. Okay, they say an exact answer in terms of pi. So you're going to type this on Desmos, but leave the pi out. So I'm going to do it on my calculator I have here, 80 over 360 times 15 squared. So I get 50 pi for my answer. So 50 pi would be the answer in square yards. Okay, pause that and rewatch if that confuses you. I'm going to do one more. This is number 9 from the MathXL, or one that would be similar to it. So number 9 looks like this. They want the area of the shaded sector. So we got it, they want this chunk. Well, the 130 is that piece. So you got to remember this is a linear pair here. So I'm going to do 180 minus 130 first to get the degree. So that's 50 degrees here. Now I have the degree of the sector. And so I'm going to take the degree out of 360 times pi r squared. Okay, I still need to get my radius. 26 is the diameter. It's all the way across. So I need to do 26 divided by 2 to get the radius. And 26 divided by 2 is 13. So 13 is my radius. So I'm going to put 50 over 360 times pi times 13 squared. All right, they want it in terms of pi again. So you're just going to type in 50 over 360 times 13 squared. Okay, what kind of answer? They want an exact answer, so they will not like that crazy decimal there. So I'm going to change it into a fraction. So 845 over 36 pi would be your answer. 845 over 36 pi. Okay, hopefully that helps you. Email me if you need more help.